안녕하세요. 김용진 원장입니다.
Greetings, I'm Dr. Kim Yong-jin. In this online master course, I'm going to talk about the advantages of OneGuide template and the printing process. Digital guided implant surgery has become truly mainstream. Different implant companies have introduced dedicated digital guided surgery systems. There are different advantages for surgical templates in different companies. In order to use OneGuide system well, you need to understand the advantages the template has. You need to have such understanding to be able to have digital guided surgery without complications. So I'm going to talk about the advantages of OneGuide template. This is OneGuide template. First, let me talk about the disadvantages of guide system with metal sleeves. In the case of guided systems with metal sleeves, you need to adjust the minimum thickness of metal sleeve. Therefore, the thickness becomes wider. In placing single implant, the minimum mesiodistal width becomes much more compared with OneGuide system without metal sleeve. Therefore, the area where it can be applied is more limited. In the case of a OneGuide template, the minimum mesiodistal width needs to be at least 6 mm. However, in the case of metal sleeve, it is known to be 6.6 mm. In doing single implant placement, there can be many limitations. If you use metal sleeve and directly place a guide drill that rotates at a very high speed, because of friction between drill and metal sleeve, the metal bits from metal sleeve can come off. If you use key or if you use that to rotate 2.0 diameter drill in high speed, then the lateral wall can be grinded off. Metal debris is heavy, so it can stick to gingiva. Through the drilling site where implant should be placed, what if metal debris sinks down? It will interfere with osseointegration of implant, and there can be post-operative infection because of that. In applying high-speed drilling system, I do not recommend using metal sleeve. In the case of guide system with metal sleeve, as you can see, the mechanical interlocking between metal sleeve and guide hole can be loosened upon continuous drilling. Bonding agent is not used to attach metal sleeve and guide. Therefore, metal sleeve, which is fixed with mechanical interlocking, can be loosened with continuous drilling motion. Also, positioning error can result because guide hole is produced through 3D printing and metal sleeve is stock abutment. Because of such error, when implant is placed, because of metal sleeve tilting, there can be angular deviation of the implant. Therefore, I do not really use guides with metal sleeve. In order to make evidence of such, I did a clinical evaluation of accuracy of OneGuide. I worked with Professor Tallarico in Italy and did multi-center research. Because Noble Guide, which was the first digital guide surgery system, had a metal sleeve, many people believe that metal sleeve assure the accuracy of guided surgery. I do not believe so. 3D printing technology has developed immensely, and digital guide surgery templates without metal sleeves can ensure accuracy sufficiently. In 2018, research data was published in a journal. OneGuide template was used, OneGuide kit was used for drilling, and TS3 implant was placed in one group. Conventional OneGuide template, in other words, OneGuide template without metal sleeve was used, and in another group, a specially fabricated metal sleeve OneGuide template was used. For drill, all drills included in OneGuide kit was used and TS3 implant was placed. The pre-op planning data and the post-op CT data were superimpositioned and 4 parameters were measured. Observations were made as to whether there were any deviations from entry point in apex area and whether there were any vertical error and angular deviation. Before publishing a research paper, the hypothesis was that the positioning error of metal sleeve will lead to vertical height error of the implant. Also, the hypothesis was that upon implant placement or drilling, the tilting of metal sleeve will lead to implant's angular deviation. If you look at the conclusion, surgical templates without metallic sleeves were more accurate in the vertical plan and angle compared to conventional template with metallic sleeves. In other words, OneGuide template printed from a high-performance 3D printer, even without metal sleeve, can be more accurate. By not having metal sleeve, sleeveless design OneGuide template has many advantages. One of the most prominent advantages is that 2 types of design is possible. You can choose between closed type and lateral open type. If the patient cannot open mouth sufficiently, and if the bone quality is very hard, and if sufficient irrigation is necessary, you can choose lateral open type guide hole. By using this, the amount of mouth opening can be reduced significantly. Lateral approach or lateral open type guide can be used, and in that case, you can approach it laterally, therefore the amount for the patient to open mouth is reduced. In the case of metal sleeve, where only vertical approach is possible, it requires the patient to open mouth much more. In terms of avoiding interference with antagonists, the lateral open type can be beneficial when you're drilling in the most posterior area. Using this lateral open type can be more favorable for surgeon and patient. The 2.0 drill, and to maximize metal sleeve's accuracy, if you add a key, you can only access it vertically. If there's slightest deviation, metal sleeve can be grinded or you will not be able to approach it, so it's not really comfortable for the patient. I don't think this is a guide system that satisfies both the surgeon and patient. If the patient can open mouth well, it's fine. As you can see, it's very difficult to approach. My assistant and I am forcefully opening the patient's mouth. Even if you go in as drilling is performed, unless the level of mouth opening is maintained, there can be fractures or tilting as we pull out the drill. It's difficult to remove. In this case, if you twist it, the 2.0 diameter initial drill can fracture or the guide hole can fracture. It's very cumbersome and it can be very painful for the patient. You can see how difficult it is to remove it. It's very difficult to gradually expand the drilling in this case. We can face these situations, therefore I use OneGuide template without metal sleeve frequently. In the area where bone quality is anticipated to be good, I choose lateral open design intentionally to do sufficient irrigation. When I am placing single implant in number 47, I use lateral open guide hole, and from the lateral side, drill and implant is approached. This makes drilling easier and faster, and implant placement is also made easier. We also need to understand the template's height offset concept when we're using digital guided system. The offset is the distance between planned implant top to the fabricated guide hole top. This is a fixed value and is different by guide system. If implant is placed equicrestal, the distance from implant top to guide hole top is offset, and in the case of OneGuide, this becomes 10.5. This is a value that does not change. And even if an implant is placed bone level, if the tissue is thicker, guide hole becomes thinner because the distance is the same 10.5 millimeter. Under the assumption that gingiva thickness is the same, and if implant has been placed deep subcrestally, you need to consider the amount of gingiva thickness, guide thickness, and how much subcrestal the implant has been placed. This leads to reduced guide hole thickness. As shown, implant's vertical position is determined while adjusting the thickness of guide hole. The basic value used is offset. Among guide systems from other companies, there are systems where offset value can be changed. 9mm basic offset, 10.5 and up to 12mm depending on clinical situation, whether thick gingiva or if the implant needs to be placed subcrestal significantly, then intentionally offset amount can be increased, but most of the implants that we use these days are taper body implants. In order to apply different offset values, the drill type needs to be straight instead of tapered. Therefore, at times, the drilling hole and implant do not sync well. As a result, I do not prefer digital guide systems with varying offset values. I like fixed offset because when placing a tapered body implant, the fixed type is much more favorable. When you look at the digital guide surgery workflow, you take a CT and do surface scan. You either take impression or use intraoral scan and merge the two data. These are primarily done at Osstem OneGuide Center, and planning and guide design is performed and guide is printed out. The 3D printer is used. Let me show you a brief video clip about OneGuide template design. This is my actual case. I've sent the model to the OneGuide Center and model scanning was done. CT was used to merge the two information. The tooth contour were superimpositioned. Prosthodontic design was performed. In the area to be restored, crown size, length, and position inclinations are adjusted. After that, on CT data, implant library is used. The Osstem TS3 and TS4 implant library is used for implant planning. On CT data, ideal implant position and inclination is confirmed, and following that position, a guide hole which allows implant to be placed in that position is fabricated. Once implant placement plan is formed, the guide hole is formed first, and the rest of the areas that support the guide hole can be referred to as the template. Simply put, digital guided surgery is where guide hole is fabricated in order to place the implant in the planned position, and the template supports the guide hole. Once implant position is confirmed on the program, rough guide design comes out. Rather than doing it yourself, in most cases, OneGuide Digital Center would be in charge of it, but to understand the process more, video clip has been prepared, and then guide design process. Guide is formed following the implant path, and following the implant's vertical position, guide hole height and direction is determined, and guide is fabricated in this way. Once design is complete, the guide file is printed out using 3D printer and is delivered to our dental clinics. If you have 3D printer in-house, especially if you have OneJet DLP or LCD, you can print it out yourself. If you have planning programs such as Implant Studio, where you can plan yourself, you'll be able to do OneGuide planning and printing at the same time. Through Digital Master Course and Offline Master Course, I'm going to address how these data are processed and what goes on the program, as well as how 3D printer is used in reality. Thank you.